Welcome to this explainer. Today we're diving into something really cool. We're going to explore how modern interactive technology is completely redefining science lab safety. Now, if you've ever stepped foot in a high school chemistry lab, you probably remember that lingering, slightly terrifying fear of accidentally blowing something up, right? The environment can be incredibly complex. Well, today we are looking at how educators are utilizing immersive digital tools to ensure that students can learn effectively without ever being exposed to those real-world hazards.
So, this brings us to a really critical question. How exactly can educational institutions let students handle hazardous materials without the real-world risks? You know, students come into science programs from incredibly diverse backgrounds, and often they have absolutely zero hands-on training when it comes to handling volatile chemicals or delicate, super expensive equipment. Obviously, we want them to learn and we want them to experiment, but fundamentally, we have to protect their health and safety. So how do we bridge that gap?
Okay, here's our roadmap for the explainer today. We'll start with the limits of traditional labs, then enter the virtual lab, explore how zero risk means maximum learning, check out a virtual experiment in action, and finally, look at upgrading the science curriculum. Let's get into it.
Section 1. The limits of traditional labs. Let's start with a very real problem that educational administrators and teachers are facing every single day. For decades now, we've relied heavily on traditional safety lectures and static reading manuals to prepare students. But here's the thing. These passive methods simply fail to prepare students for real, sudden hazards. We're talking chemical spills, toxic exposure, or even fires. Why? Well, because passively listening to someone talk about safety doesn't actually build practical muscle memory. Ensuring lab safety isn't just about handing out a laminated list of rules. It's about how effectively those rules are understood, practiced, and then applied in a highly stressful moment.
And the stakes here are incredibly high. Human error is literally the leading cause of lab accidents. When a student makes a mistake in a physical lab, it leads to damaged, highly expensive equipment, massive institutional liability issues, and of course, potential physical injury. But there's another hidden cost here that we don't talk about enough: student anxiety. When learners are terrified of making a costly mistake or hurting themselves, they really lack the confidence needed to truly engage with the science. Basically, fear becomes a massive barrier to learning.
Which brings us to Section 2. Enter the virtual lab. So, how do we fix this dangerous gap in science education? Enter virtual labs. Platforms like PraxiLabs provide an immersive, 3D digital environment that totally replaces static instructions with fully interactive safety training. Guys, this is a real game changer. Instead of exposing students to dangerous chemicals or volatile reactions right off the bat, these platforms create a completely risk-free space where learning thrives without ever compromising student health or institutional budgets.
By definition, a science lab safety interactive simulation is essentially a controlled digital space. It perfectly replicates real-world scenarios, allowing students to safely encounter and manage chemical, biological, or physical materials. They actually have to actively navigate the procedures, the guidelines, and the precautions. It's hands-on learning, but with absolutely zero real-world hazards.
Moving on to Section 3. Zero risk, maximum learning.
What's really fascinating here is how these virtual environments directly translate to way better academic outcomes. First up, there's safe exposure. Simulations allow students to safely experience the real consequences of their mistakes, things like equipment failure, contamination, or, yes, even explosions, without any actual danger. Second, interactive learning and gamification are proven to increase focus and significantly improve long-term memory retention compared to just, reading a boring manual. And third, infinite scalability. This interactive safety training can reach massive numbers of students anytime, anywhere, completely bypassing the physical capacity constraints of traditional brick-and-mortar laboratories.
And hey, the proof really is in the data. Check this out. A fascinating case study looking at the integration of virtual labs in high school physics showed a massive 25% improvement in test scores when students use virtual labs compared to traditional teaching methods. To put that into perspective, that's the difference between a C and an A, driven simply by changing the medium of practice. That is a staggering leap in academic performance. Researchers noted exactly why this 25% jump happened, stating that the simulations allowed students to explore complex concepts in a highly interactive and visually immersive manner. But beyond just boosting grades, this success created a wonderfully positive shift in students' overall attitudes towards science. By stripping away that paralyzing fear of making a costly or dangerous mistake, students felt way more prepared, far less anxious, and actually empowered to experiment and satisfy their scientific curiosity.
Let's look at Section 4, a virtual experiment in action.
Let's ground this in a tangible scenario, shall we? PraxiLabs features a specific simulation for testing arsenate. Now, this is a highly toxic chemical procedure. Before a student even touches a virtual beaker, they have to learn the instructions, review the chemical's safety data sheet, which is basically the extreme warning label, and understand every single lab safety sign.
To really build that muscle memory we talked about, the safety protocol is broken down into 3 crucial, distinct stages that students must actively navigate in the digital space: before entering the lab, right beside the lab door, and finally, inside the lab itself.
So first, in the transition corridor before even entering, students must interact with an instruction board on the wall and physically click to put on their virtual lab coat, goggles, and gloves. Next, standing beside the door, they must identify and click on prohibitory signs, which actually triggers pop-ups reinforcing those specific rules. Finally, once they step inside, a warning pop-up introduces the safety equipment, and the digital view literally pans across the room to show the student exactly where every single piece of emergency equipment is located. They are actively mapping the physical space in their minds.
And finally, Section 5, upgrading the science curriculum.
The really beautiful part about all of this is how seamlessly this life-saving technology integrates right into your existing institutional framework. Platforms like PraxiLabs offer a perfect curriculum fit. They provide over 210 STEM simulations that are already mapped out to standard academic syllabi, meaning educators don't have to spend hours redesigning their courses from scratch. And if you can't find exactly what you need, the experiments are customizable, even across different languages. Plus, they feature integrated quizzes and back-end analytics, allowing educators to easily track student progress and ensure learning objectives are being met, all while giving students the flexibility to learn at their own pace, anytime, from anywhere.
As we wrap up this explainer, I want to leave you with this provocative thought. We've seen exactly how passive reading totally fails to build safety muscle memory. And we've seen how immersive, interactive environments dramatically boost test scores and eliminate student anxiety. So, with risk-free, highly engaging, and infinitely scalable virtual solutions now readily available to educational institutions, is it time we make physical lab accidents a thing of the past? Thank you so much for joining me for this explainer, and I highly encourage you to keep exploring the fascinating, innovative ways technology is elevating how we learn.